Yay!
Yay! All right. Another pretty typical problem that we're going to find in most books is a network of resistors and batteries or voltage sources that can't be broken up into simple series and parallel combinations. And these are typically called multi-loop circuits. And for this, we have to do a different kind of analysis. And what we do is we just invoke the rules, the Kirchoff's law's rules for junctions. So we're going to look at this junction up here and loops. And the idea is that the sum of the voltages dropped around a loop have to be zero. I guess that's not, the sum of the voltages around a loop have to be zero. Some are gains and some are drops, right? But when you add them all together, it should be zero. And then at the junctions, the idea is that you don't lose any current. So whatever goes in comes out. That's it. Those are the rules. So using those rules, let's see if we can find out. The name of the game is to try to find out what the current through these resistors, the currents through these resistors are. Because in that way, we can then find out if we wanted, we could figure out what the power was, right? Find out how bright each of these light bulbs were. Okay, so what we're going to do is evaluate loops. There are 3 loops in that picture. There's the left loop, the right loop, and then there's the big loop around which charges could flow. So for each of those, I'm going to write down a loop equation. All it is just summing voltages around a loop. Okay, so I'm going to do that. Now what I want is currents through those resistors, right? So there's going to be 3. I got 3 unknowns. I got I1, I2, and I3 through each of those resistors. I don't know what they are. So something tells me I'm going to have 3 equations involving those to figure it out. If I got 3 unknowns and 3 equations, then it might be tedious, but you can do it. Just lots of substitutions and stuff. I can solve 3 equations and 3 unknowns, and then I got it. Okay, so let's write an equation. Let's write a loop equation for each one of those loops. So I'm going to start with left. Now, what I suggest is just always do the same thing. That way it's a little harder to be confused. And I never care what my students do. I don't care which direction you go, but just pick a direction to traverse the loop. Pick a direction to go around the loop. I always go, for some reason, counterclockwise. So around every one of these loops, I'm going to go around it counterclockwise. Okay, that's the first choice that you have to make. And for me, if I do the same thing every time, it's really not even a choice. Okay, next. The next thing is that you pick a direction for the currents through those resistors. And what's nice is that it's arbitrary. You can pick whatever you want as long as you're consistent. So what I recommend is just writing them down. So here we go. I'm going to say that through the R1 resistor, I'm just going to pick the current's going to go that way. I don't know if it is or not. We're going to find out. What's going to happen is if I choose any one of these wrong, if it's actually going the other way, I'm going to get a negative answer. I'm going to get my current has a negative answer, which is totally fine. That just means I picked the wrong direction. But I'm going to get the right magnitude. I'm going to get the right answer. So it doesn't matter what you write down. You can write either direction, and it's just going to be fine, but you just have to be consistent. Okay, for R2, what do I choose for R2? For R2, I'm going to imagine that the current's going up like this. That's my prediction. And then R3, the current's going like that. So in particular, at this junction, what's going to be happening is that I'm going to have a current going in like this, and like that, and like that, right? This is going to be I1. That's going to be the current through 3, and this is going to be the current through 2, right? Into that junction. Okay, we'll write down an equation for that in just a minute. Okay, so let's write down for the left loop, let's write down an equation. Here's the rule. If I'm traversing the loop and I go across the battery from negative to positive, here's the positive, the long terminal is the positive terminal. So if I go from negative to positive, That's in the forward sense of the battery for conventional current. So that's a plus sign. So what I get is, I'm going to get a 28. All of these are volts, right? This is a voltage equation. So I'm summing all the voltages around that loop. So I get a plus 28 coming across the battery. And then look, I'm going across another battery as I go around. Ooh, this is a good time for the laser pointer. As I go across this battery, I get plus 28. And now I'm going to go across this battery the wrong way from positive to negative. So that's going to be a minus 42, right? And now I continue to come up. Now I'm going across this resistor. I'm going across R2 in the direction of the current, right? I said that the current was going up. So in the direction of the current, what do you do across a resistor? You drop voltage. So if you go with the direction of the current, this is what gets a little confusing, you get a minus sign, minus IR. That's the voltage dropped, right? So it's going to be 6 is the R times I2. There's my IR across that resistor. All right, and then as I continue to go around this loop, here I go, and then I go across R1 in the direction that the current is going through R1, so it's going to be a minus 5 I1, and all of these together have to be 0. Okay, so there's my first equation. How about what's next? Right. Let's do the right loop. Okay, so the right loop, I'm going to start again at the battery. Now it's the 42 volt battery. So now I'm going counterclockwise around that loop. So I'm going from minus to plus. So it's going to be a plus 42. And then I'm going to go up this way in the direction of the current here. So it's going to be minus 3 or 3I3. And then look what happens. Then I come, as I go around the loop, I'm coming around this way. I'm going opposite to the current, right? As I'm traversing the loop, I'm going opposite to the current through R2. So opposite to the current, that's going to pick up a plus. So now I'm going to have a plus 6I2, and now I'm back at the battery. So all that has to equal 0. All right. Next, let's do the big loop. For the big loop, let's start over at the 28 volt battery. So now let's kind of do it in our heads. I get a plus 28 because I'm going forward across the battery. And then I go over to R3, so that's just going to be minus 3I3, minus 3I3. I'm going in the direction of the current. And then I'm all the way, so I'm doing this. I just went through R3, and it's the big loop, so I come all the way around, and I'm going with the current through R1. So I do a minus 5I1 equals 0. That's a goofy 0. 0. All right. Oh, and then I can't, okay, they're my 3 equations, right? I could stop there, but it's useful to write down the junction equation because it gives you one more equation and it's an easy one. So let's do that. So we actually have 4. We have too many equations, but that's okay. So the junction equation, if I look at that equation up there, I've got I2 and I3 are both going in and I1 is going out. So whatever goes in has to come out. So it looks like I1 has to equal I2 plus I3. That's why we usually want to write that one down, because it's easy. We'll take an easy equation anytime. So all I have to do is pick out any 3 of these. Probably I'm going to include the junction because it's easy. So I'll choose the junction plus, let's do this one and that one. And then we'll figure out what these currents are. Now it's just a matter of, like, you know, whatever it was, 10th grade math or whatever, trying to figure out 3 equations and 3 unknowns. Let's see, this one looks like I can simplify this one pretty easy. If I divide everyone by 3, looks like, what is that what I did here? Yep, that's what I did here. If I divide everyone by 3, this tells me that I3 3 is equal to, let's see, 42 divided by 3. That's going to be 14. So it's going to be 14 minus 2 I2. That looks right. And then this one, let's look at that one. 28 minus 42, that's going to be minus 14 minus 6 I2 minus 5 I1 equals 0. But now, let's use that. And we're going to throw that in for I1. Okay, let's write these down here. I got minus 14. Here's my left equation. Minus 14 minus 6 I2 minus 5. I1 is I2 plus I3. Minus 5 I2 minus 5 I3 equals 0. Okay, so that's minus 14 minus 11 I2 equals 5. And now I know what I3 is, right? I3 from here is going to be 14 minus 2 I2. So look, now I can figure out what I2 is. So I have minus 14 minus 11 I2 equals 5 times 14, 70. So I got 70 minus 10 I2. Let's see, so I2 is going to equal, let's see, I got 1470 minus 84. Let's see. Oh, I made a sign mistake, didn't I? Up here, that should be 14 plus. See how easy it is to make a mistake. 14 plus 2I2. Okay, so that's going to be a plus and a plus. So this is going to be, if I add this to the other side, this is going to be 21 I2. Okay, so here we go. I2, once you get one, they all sort of start falling like dominoes. So I2 is minus 4 amps. All right, so what that's telling me is that the current through resistor 2 is 4 amps, but it's really going this way because I got a negative sign. So I was wrong by predicting it's going to go up. It's going to go down. It doesn't, whatever, it doesn't matter. Okay, neat. So if that's my I2, let's go and find one of the other ones. Now, let's see if I know that that's I2. Oh, I can find I3 really quick. So I3 is 14 plus 2 I2. So I3 is going to be 14 minus 8, or 6 amps. Uh, 14 minus 8, 6 amps. So I3 really is going up through that resistor, and it's got a value of 6 amps. And now I'll just use the junction. Now I can have I1, right? They all start falling into place. So I1 is just those two added together, or 2. All right. So now we know the current through each of those resistors and their directions. So if you want, you could find the power, then I squared R for each one as well. Just to make sure that we didn't make a mistake, if you're ever taking an exam or doing homework or whatever, it's good to just take a few minutes. Since we had too many equations, we took the trouble of writing them all down. Let's throw these into, or whatever applies, let's throw them into the equation for the big loop. And let's just make sure that everything is okay, because it ought to satisfy the big loop equation too. So this means that 28 minus 3 times 6 minus 5 times 2 equals 0. Is that going to be okay? 28 minus 18 is 10, minus 10 is 0. Okay, that looks just fine. So this is how you can kind of ferret out mistakes. We solved using left, right, and junction, but go ahead and take your numbers and plug them into the other equation because it ought to satisfy that too. So that kind of leads us to believe that we're okay. We didn't make a mistake. Everything is fine. Okay, so the moral of the story is be consistent with your directions around the loops, and just remember the rules for going with or against the currents, and then don't blow signs like I did, and then you should be okay, right? Okay.